Dear students, Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to a new lesson for grade 8 in geometry, and the lesson title is The Medians of a Triangle. Here we have the learning outcomes of this lesson. By the end of the lesson, you should be able to define the median of a triangle, understand the theorems of medians of a triangle, apply the theorems of medians on exercises. First of all, let's recall what is a triangle. A triangle, as we took in the previous years, is a polygon containing 3 sides, 3 angles, and 3 vertices. Here is a triangle named ABC, and we name the triangle according to the 3 vertices. We have 3 sides, AB, AC, and BC line segments. We have 3 angles, angle A, angle B, and angle C. And we also have 3 vertices, A, B, and C. Now let's see what is the definition of the median of a triangle. The median of the triangle is the line segment drawn from any vertex of the triangle vertices to the midpoint of the opposite side of this vertex. Here we have in triangle ABC, AD is the median of the triangle ABC. The median has 2 conditions. First condition, that the median is a line segment drawn from any vertex of the 3 vertices of the triangle. The second condition is it should be drawn to a midpoint on the opposite side. Here we have D, a midpoint on BC, and A is a vertex of a triangle. Then we should consider AD as a median in this triangle. This is a very important point to remember, that any triangle has 3 medians. Theorem 1 of the medians. The medians of the triangle intersect at one point. As we said that any triangle has 3 medians, and according to this figure, we see that the 3 medians intersect at one point, which is point M. As mentioned here, that AD intersection BF intersection CE equals point M. The point of intersection of the medians has different names. Point of concurrence of the medians, the triangle's centroid, or the center of mass. The point of intersection of the medians and the point of concurrence of the medians, you will find it in the Egyptian and the British curriculums. But in the American curriculum, you will find the name of the point of the intersection of the medians is the triangle's centroid, or the center of mass. Theorem 2 of medians. The point of intersection of the medians in the triangle divides each of them by the ratio 1:2 from the base, or by the ratio 2:1 from the vertex. Here we have a different rule. Each median is divided into 2 ratios according to the point of intersection of the medians. Here we have M divides AD median to AM and MD. We can say here that the point of concurrence, or the point of intersection of medians, divide each median into certain ratio. AM to MD, or as we go from the vertex to the base, the ratio is 2:1, which means that the length of AM is double the length of MD. On the opposite direction, if we go from the base to the vertex, then we will go with the ratio 1:2. DM to AM is 1:2, or the length of DM is half the length of AM. From this rule, we can deduct 2 important points. The ratio of AM to AD is 2:3. AM to the whole median is 2:3, because AD here is the sum of the 2 ratios, which is 3. So AM to AD is 2:3. On the other hand, MD to AD is 1:3. These ratios and these points are very important to understand the medians. Now let's apply the rules of the median on this exercise. First, let's pick up together the given information from the drawing. We here have AE, a median in the triangle ABC, because E is the midpoint of BC and A is a vertex. Also, we have CD, a median in the triangle ABC, because C is a vertex and D is a midpoint on AB. Then, the intersection of the 2 medians is the point of concurrence, or the point of intersection of medians, which is the point that apply the ratio 1 to 2 from the base or 2 to 1 from the vertex. The example says that the length of CM is 8 cm and also the length of ME is 3 centimeters. Now let's move on to the points we need to answer. First, we want to calculate the length of MA. Here is MA. So MA is the part of the median from the vertex, and as we know from the rule that it is double the part from the base. And if ME equals 3 cm, then MA is double that length, which is 6 cm. Then MA equals 6 cm. Moving on to MD. This is the part of the median which is near the base. And as we know from the rule of the medians that MD is half the length of MC, or the part near the vertex. And if MC equals 8 cm, then MD equals half that length, or 4 centimeters. Now we need to find the ratio between ME and AE. ME, this part near the base, and AE, the whole median. And if we remember the ratios that we read before, ME, the part near the base, will take the ratio of 1, and the whole median will take the ratio of 3. So we can say here that ME equals 1 over 3 of AE. The final point, we need the ratio between MC and CD. MC and CD. MC is the part of the median near the vertex, and CD is the whole median. So the ratio between them is 2 to 3, or we can say that MC equals 2 over 3 of CD. Continuing the application on medians of the triangle, I need you to answer the exercises in your booklet, pages 65 and 66, and hand them to me in the class. The final part of our lesson, as usual, is to sum up our lesson objectives. Today we define the median of a triangle. We understand the theorems of medians of a triangle. We apply the theorems of medians on exercises. By the end of the lesson, I thank you all for watching this video and wish you all to see you safe and sound, and see you in another videos inshallah. Wassalamu alaikum wa rahmatullahi wa barakatuh.